Hello everyone, am I audible? Cool. Uh, just a minute. Cool. Uh, yep. Okay. Is it better now? Cool. So we completed about the Facebook's design yesterday, Facebook Messengers, Facebook News Feeds design yesterday in the last class. So now we would actually want to discuss one more problem, or we would actually want to expand our problem and see how is the problem at Facebook really handled for news feeds. Okay, so one thing that we did till the last class was that how many data centers were we assuming, folks? How many data centers were we assuming? Only one, right? We were assuming that everything that we are doing happens within a data center. Does that make sense? And do you guys actually recall at the very beginning, maybe in the first or the second class, I told you that for big organizations or for big internet companies like Facebook or Google, you would actually be seeing that the DNS servers has more than one IP for those systems. Do you guys remember that? Okay. So what will happen actually? Facebook is not going to be based out of one data center. Facebook would actually have multiple data centers across which it is going to save all its data. So let's say there is one data center for Facebook, which is the US East Coast. Let's say there is one data center that Facebook has on the US West Coast. Let's say there is one European data center that the Facebook has. And let's say there is one data center in India, and so on and so forth. So there are several data centers now for Facebook. Okay. And also in the DNS servers across the entry for facebook.com, you no longer only have one IP of the load balancer, but you have multiple load balancer IPs. Does it make sense, folks? So let's say there is a load balancer for the US East Coast data center. Let's call it L1. The IP of the load balancer is L1. Let's say there is a load balancer for this US West Coast, a load balancer for Europe, a load balancer for Indian data center. Does it make sense, guys? That data for Facebook. So basically, Facebook data center is not going to be a single data center. They are going to have data center across the world. Okay, cool. Now for every data center, they are going to have a load balancer IP. Okay. Yes, Moise. So even if you are looking at a cloud-based infrastructure, you would understand that cloud is nothing but, again, a group of data centers. Does that make sense? So let's say you're talking about AWS. AWS's servers would be spread across multiple geographies of the world, right? So irrespective whatever, let's say you are just using out of the box cloud solutions, or you are building data centers of your own, the solution remains the same. Fundamentally, the things remains the same. Okay, cool. Right. Makes sense. Now, why do we actually want to have different data centers? Okay. So first of all, do you guys agree that having different data centers would allow you to spread your load properly, right? Spread your not only the computation load, but also the network load. Does it make sense? It will also divide the network load. So let's say you have so many boxes only at one physical location, then the problem would no longer be the compute time it takes, but the network would start getting to choke. Does it make sense, people? Right. So network would start getting to choke. This is one simple reason, but a very, very big reason of actually spreading out across multiple geographical locations is that you want to indemnify yourself against region specific outages. So what does that mean? So let's, for example, assume that let's say the optical fibers connecting India unfortunately, or let's say not India, why talk bad about India? Let's say that let's say that the data center in Europe is no longer accessible due to some very bad happening. Okay, let's say something bad happened, maybe the network is down, or let's say some natural calamity happened, or let's say in US East Coast there was a flood or a hurricane and the data center is lost now, right? So these big organizations would want themselves to be indemnified against these region specific outages. Does that make sense to you guys? So just because, so you are actually dealing with physical stuff, right? Whenever you are dealing with physical stuff, you would want to realize that all these things are prone to natural disasters. There can be a flood, there can be a fire, etc., etc. So you would want to actually spread across the geographies of the world so that your system as a whole does not go down. Cool. Now, do you understand that the moment you spread out your system across multiple geographical locations, the problem, the complexity of the problem that we discussed in the last class actually increases many folds? Do you guys appreciate that? Right. So how many of you are feeling lost? Try to appreciate that the moment you have your data spread across multiple geographical locations, it's no longer something which is just happening within one data center, no longer something which only has exposed a single load balancer to the outside world. It has become a bit more complex now. So in today's class, we are going to dedicate the first half of today's class in trying to handle these kind of complexities where systems become too big that they actually have to spawn across multiple geographical locations. Okay, cool. So very first thing that changes, this also helps in network lags. Yes, this would, Nikhil, because now you actually have options. So let's wait for some time. Let me discuss the entire approach and the approach that I'm going to discuss would be as close as possible to what Facebook actually uses. So let's just wait for a while and then we'll take up these questions. Okay, cool. Yeah. So the very first thing, won't this be a bit heavy on the maintenance side? Makes sense to say that would definitely be a bit heavier on the maintenance side. So maybe that is why you would see more and more startups these days actually falling back to cloud service providers, right? Actually utilizing, let's say, AWS or other cloud service providers so that they outsource that problem of maintenance to to some other organization and getting all the benefits of spreading out yourself to multiple geographies, right? But for the big organizations like Google, Facebook, Amazon, they would not want to, let's say, use a third-party cloud service because they are too big. The data that they have is too huge that they can very well utilize the economies of scale and actually build an economical solution for themselves. Does that make sense, Jose? I hope it does. Cool. Right. So now the very first thing that changes when we actually have multiple data centers is that you would be having multiple entries in the DNS server. Does that make sense? So we discussed that day that there is an organization called as ICANN, which actually maintains the root DNS servers. And Facebook can just go to ICANN and tell them that, hey, we have this kind of a load and we would want to have multiple load balancer IPs in the DNS servers. So please allow us, and they would allow them. And now they, let's say, have multiple load balancer IPs. Now, whenever a client hits the DNS server and is asking for an IP for facebook.com, if this happens to be a normal DNS server, what will it do? Let's say it has these mappings: facebook.com, IP1, IP2, IP3, and IP4. So what will it do? As I told you before, it will reshuffle these four IPs. It will just shuffle these IPs and will return back a random ordering of IPs to the client. So let's say IP2, IP3, IP4, and let's say IP1. Does that make sense, folks? So now you are actually going to get, the client is going to get a random shuffled ordering of the IPs. Now the client would most likely follow a waterfall model, which is that it will first go to the first IP in the sequence. If that is the IP that is responding, it will establish a connection there, get all the data that it wants from there. If that IP is down, it will go to the second and then to the third to the fourth in a waterfall manner. Okay, does it make sense, folks? So the very first thing that changes that your DNS server is not going to return a single IP but a group of IPs and in a random sorted order. So let's say the same client or any other client makes another call to the same DNS server for fb.com. It is again going to get a list of IPs but in a different order, again in a randomly shuffled order, right? So why does the DNS servers actually shuffle these IPs? Can people in the class answer that for Uzair? That is just to ensure that the load is spread as much as possible, right? So a very, very trivial way of balancing load as from a DNS server's perspective, they would just randomly shuffle it and give it to you. And you would agree with me that if you take a randomly shuffled ordering on a very large set of for a very large number of times, on average, you are going to see evenly distributed load. Does that make sense to everybody? Right. Right. Notice that till this point in time, geolocation is not at all being considered. Does it make sense? So let's say there is a client sitting in India. There is a client in India. He wants to access facebook.com. You will go to the DNS and let's say it gets the IP in this ordering: IP3, IP2, IP1 and IP4. So the very first IP that it got is IP3, which corresponds to the US server. So the client is actually going to make a call to the US server. Does that make sense? Sorry, the Europe server. Just because the first IP that it got was Europe's IP. Does that make sense to everybody? Cool. Now, this is one way of doing this. We will be actually now discussing going forward how Facebook will respond to it. Right. Sanket, let's not worry about it. I will explain it to you very, very vividly how Facebook handles it and make sure that the response is not that slower. So wait for a while. But till this point in time, you know that DNS is a third-party organization, right? You cannot force how it should be behaving. So if it behaves in a simple randomly shuffled ordering, that's good enough. And we cannot complain about it. Okay. This is the first kind of DNSs that we have. But now these days, we also have geolocation based DNSs. Not every such DNS server would be a geolocation based server, but you can configure some of the DNS servers to be geolocation based servers. So what would they do? They would look at the geolocation of the client and would try to return the IPs in such a manner that the first IP they return should be the closest to the client. Does that make sense? So yes, there are geolocation based DNSs as well, but this is something which is not a reliable mechanism to rely upon. This is something which can happen, which may not happen. Does that make sense, folks? Okay. Vijay, that's a big question, and I'm going to utilize the next 30-40 minutes to answer that. Pratmesh, these are different domains altogether. So if you have .co.in or if you have .com, you would realize that these are different domains altogether. Does that make sense, Pratmesh? So that is Google's way of saying that I am going to expose the same service at different locations with a different domain name altogether. Okay, cool. Makes sense. Now, Uzair is saying, why is it not reliable? So Uzair, by that I just meant that there are going to be some DNS servers which are going to be geolocation based. There are going to be some others which are not geolocation based. Point one. And point two, why would you want to give your control of how your users should be routed to a third-party DNS? Does that make sense, Uzair? So why would you actually want to rely upon a third party and say ki whatever they do, that's fine with me? The control should actually be at Facebook's end, and whatever system they design should be assuming that any client can land up at any IP. Does that make sense? Okay, cool. Yeah. Uh, let's actually now go to the design that we had in the previous class for Facebook, and then we would try to change it so as to spread across multiple data centers. Now, Kaustubh says, but let's say India has the most Facebook users, so all the load will be on India data centers first if you use geolocation. That's again a great point, Kaustubh. So Kaustubh says that what if all the DNSs were geolocation based, uh, were actually were actually routing using geolocation. The problem in that case would be that, let's say, uh, Facebook has so many users in India as compared to so less users across the world, right? And if Facebook has so many users in India, if every DNS is just doing geolocation based sharding, all the Indian users will be routed to the Indian data center. Does that make sense? Do you realize that that also leads to unequal load amongst data centers, right? And would Facebook want to do that? Maybe not, right? That is not the best, most optimal resource utilization that you can do. So it's always better to have the control in your hand rather than just assuming that things would fall in place themselves. Okay, point. I hope the point is well taken by the class. We can put more data centers in India. Okay, Neeraj. So okay, that makes sense. But let's actually look at a more seasonal problem. So what is seasonal? Seasonality in the number of requests that you see simply means that do you see a regular trend which is repeating trend, right? So let me tell you a very, very simple seasonal trend, which is that, let's say, when it's daytime in India, let's assume, with all good faith, that people use Facebook more in daytime. Let's assume that. Okay. So now, if it's daytime in India and it's a night time in US, let's assume people in the US are sleeping and there is considerably low load on the US data center, and there is very high load on the Indian data center. Okay. Now, would you want to add more data centers for India, even when the data center in US is relatively less occupied? You would not want to do that, right? So you would want your users to be distributed in such a manner that at every given point in time, you are utilizing your resource the most optimal manner you can. Does that make sense, Neeraj? So just to actually, just because these seasonalities occur all the time and they are actually embedded in the way world works. So you can actually exploit those seasonalities and distribute your load more properly across all data centers in the world. Neeraj, does that make sense? And does that make sense to everybody in the class? Neeraj, if you have any doubt, I can unmute you. Okay, cool. Uh, cool. I'm waiting for a reply. Okay. So Sanket has a doubt. One doubt. All data centers have data of all. Okay. So Sanket, what data center has what data, and how does the routing takes place? How does the functionality of the system still work? We are going to discuss that. So that's a big chunk of what we are going to discuss in today's class, Sanket. Okay. Cool. Cool. Let's actually look at let's actually look at how was the design that we discussed in the last class for Facebook. We have a client, we have load balancers interact with app servers, okay, and we discussed that there would be a global cache. We also discussed that there would be app server caches as well. And there would be a storage layer. And then there would be cold storage, if you guys remember that. Does everyone in the class remember this? This is what we discussed in the last class for Facebook. Now, what else did we discuss? We said that the users are sharded, or everything in the storage layer is sharded across boxes. Do you guys remember that? So for some users, you are going to see some users in this box. You're going to see the data for some other users in this box. You're going to see the data for some users in this box. Right? So users were sharded across boxes, and we discussed not only the users, but in fact, all the data that was stored in the storage layer was sharded amongst boxes. But most of the serving that used to happen from the caches. Do you guys remember that? So we did a calculation and saw that for every new post that occurs, even if we are storing every new post that occurs in the global cache, based on today's system, we can assume that we can actually cache 10 to 12 days of data of posts in the cache. And this is talking very on the defensive side. You can actually store more days of data in the cache, but let's assume that at least you're going to store 10-12 days of data in the cache. So most of the servings for the news feed is going to take place from the global cache and from these app server caches. Do you guys remember that? Okay. One more very important thing to understand, that every read you can expect to only happen from cache. You can hope that every read will only happen through cache. Some reads will definitely go to storage, no doubt about it, but every write must go to storage. Do you guys remember that? Every write must go to storage, and most of the reads we can assume happen only through cache. Do you guys remember that or not? Why I am saying every write must go to the storage? Because we do not want the data to be lost. We want the data to be persisted. So you would want every write to go to the DB as well. Cool. But why? How does this work? This actually works because the number of read requests that you're going to see in this system was much higher than the number of write requests that you're going to see. And this makes the story so well that everything falls in place, and we knew how to design the Facebook system, Facebook newsfeed. Now the question arises that now we have multiple data centers. So what does that mean? If we have multiple data centers, let's say this is US West Coast, US East Coast, let's say this is Europe, let's say this is India, let's say there's a data center in China, and so on and so forth. So now, just because you have multiple data centers, you would agree with me that every data center has a different system in it from the load balancer. Does it make sense? So there will be a load balancer for a US West Coast. There will be some app servers, and there would be some storage boxes. And every one of them will have a different global cache, right? A different global cache. Do you guys understand this? That everything will be different in these data centers. Does that make sense to everybody? Is anybody feeling lost? Very few people are replying today. I don't know why that's the case. Maybe you guys have gotten bored of high-level design. If that's the case, that's sad, because we are going to have a lot more classes still. Okay, so anybody feeling left out? Anybody feeling that you are not able to understand what we are discussing here? Cool. I hope everybody is able to understand it. Everything, all the system is now distributed across multiple data centers. Now the question arises, how does our system change? There are two ways. There are two basic ways in which you can actually redesign your system. One is that you can replicate every data across all systems, across all DCs. Does that make sense? Replicate every bit of data across DCs. Is that one way? Yes. The other option that you have, so possible options that you have, one option is that you replicate it. The other option is that you shard your data across DCs. Does that make sense? So there are two ways that you can actually hope to design this modified system. One is that you can say that I will be replicating everything across DCs. And the other way would be that I would be not replicating everything across DCs, but I would shard the data. I would say some data rests in one DC, some other data rests in some other DC, and so on and so forth. Right? So these are the two options that you have if you want to actually design this modified system. Now let me actually directly come to how Facebook manages it, and then we will have a lot of discussion. Right. Okay, so let's actually discuss the trade-offs first, and then we will see how Facebook actually manages it, and then I will explain to you why that is a very, very good approach, and then I will open up to questions, so that you guys can also come up with your approaches, and we can see why your approach may be better or maybe worse off than what approach we discussed. Okay, cool. So the very first thing is Moise says, let's discuss the trade-offs, right? Cool. So what are the trade-offs? If you say that I will be storing every data as a copy at every other place, right? And it's not only talking about some backup, you are actually talking about real working copies. Do you guys appreciate the difference between storing a backup and having a real working copy? Do you guys appreciate that? How many of you appreciate that in a class? Having a backup can simply mean that you are using a relatively poor box in which your only job is to store a backup. So having a backup can totally be different than having a copy which is totally workable, because having a copy which is totally workable would mean that you have the boxes of the same capacity, boxes of the same underlying boxes who can do the same computations, and then you are storing your duplicated data. The backup simply means that you are just maybe using some commodity hardware in which you are storing that backup just in the event of retrieving it in case something bad happens to your working boxes. So having a backup is totally different than having working copies. Here I meant the first option that we have, let's have the entire working system copied all across the DCs. The problem there would be, first of all, you are storing a lot of copies. Does that make sense? You are storing a lot of working copies, which translates to you are actually wasting a lot of resources. So whatever cost you had before, if you have 7 data centers in the world, you are just multiplying your cost 7 times. Does that make sense to everybody? Cool. Point 1. Point 2, if you have multiple copies of the same data across multiple data centers, you would realize that the problem of maintaining consistency also becomes a lot more tougher. Do you guys appreciate that? Just because you have the same underlying data stored at multiple places, you now run the risk of a much higher risk of having different data being stored at different DCs. Do you guys understand that? These are the problems that you can see if you actually just copy the data recklessly to every different DC. What are the advantages? The advantage would be that now any request, without any doubt, can be served through any DC. Does that make sense? If you have managed to duplicate your data and duplicate your systems all across the DCs, now any request can be handled by any DC without any doubt, because you would understand that all of them are uh, equally well equipped to handle your queries. Okay. Now, there is a point where Sankalp says that the availability would be much higher if you have the same data duplicated on multiple boxes, multiple DCs. How many of you in the class feel that that's the case? That just because you have the same data duplicated in every data center, the availability would be much higher. How many of you think that? There is one person who thinks that. 2, 3, 4. What about the others? So I would want every one of you to reply a yes or a no. There are 3, 4 no's. Rest everybody is saying a yes. Would want everybody to reply. Okay. What about the others? Let me actually have a poll for this, because this will actually help me understand how should I take the class forward. What should I focus more on? So let me just have a poll. So how many of you think, just give me a minute. Yeah, so guys, please actually just select an option here. Mm-hmm. Please, so many people left to vote. Please vote. Should have added another option saying not getting anything, bro. What the fuck are you asking? uh, okay, so there are 12 people remaining. Can you please reply quickly? Okay, Bodhitwa. Okay, so what are the rest of the folks doing? are they are they not in front of the computers making Maggie in their kitchens? Okay, cool. So I will end the poll even if not everybody of you have replied. So okay, so these are the results that I see. 60% of the folks say that yes, it would definitely improve availability. 40% say no, they are not very sure. So actually, this actually makes me cover some part of consistency and availability again today because this is very, very important. Folks, just having just saying that you are going to save the same data and multiple boxes at multiple DCs does not improve the availability. Okay, what was availability that we discussed? We said that if you are hitting at a box which is up, if you are making a request to a box which is up, if they reply back to you, that is called availability. Do you guys remember that? Do you remember the entire statement? If you are hitting a box which is up, and if they can reply it back to you, that is called as availability. But will that be the case here? Maybe not. If you want to maintain consistency, so just because let's say I am making a write to a box in DC, Indian DC data center, and just because if I wanted to make consistency, that box will not reply back to me saying that he has written it unless and until that box can make a conversation with every other DC and tell them to write it. Do you guys appreciate it? If I wanted to make consistency, high immediate consistency, that box will not be able to get back to me and say that, yes, I have written it, because the box will wait to maintain and establish a contact with every person else in the world and tell them to make a copy, right? So the problem there would be that if one data center is down, or let's say one box which had to make that write is down in one data center, this box which is still up would not be able to take my write request. Does that make sense? So the concept of availability is not that trivial. So I have seen many people actually misinterpreting the concept of availability. That's not the case. The point here is it always boils down to consistency versus availability if you have a partition tolerant system. Does that make sense to everybody? So that actually makes me want to cover consistency and availability a bit more today. So I will be spending maybe 20-25 minutes after we have completed discussing Facebook newsfeed for good. After that, I will take maybe 20-25 minutes to make sure that concept of availability and consistency is embedded in every person's mind. Okay. So Sanket, I will not repeat it right now. Wait for some time. We will have a discussion on it for 20 minutes. Okay. Cool. Cool, cool, cool. So let's come back here. So these are the, okay. Does it make some sense to some of you? What we just said? Right. Cool. Cool, cool, cool. Now let's come back to what we are discussing. That the moment you say your system is spread across multiple data centers, you are bound to face two options. One is that you would want to replicate every bit of data across every DC, or you can say that I would just be not replicating it, but instead sharding it, right? These are the two options that you have. Now let's actually see what does Facebook actually do. Okay. Now let's actually see what does Facebook actually do. Okay. What is the Facebook's solution to this problem? Okay. So in the meanwhile, Sukanya says, if the first option of replicating isn't good, why are we even considering that as an option? Okay. So Sukanya, I did not say that that option is very, very bad. I told you some pros. I told you some cons. Now what we are going to discuss, we are going to see what makes most sense for this problem that we have, right? In design, in high level design, you should never make a sweeping statement saying that this option is never going to be good, right? It's always about choices that you make based on the problems that you have. Okay. So never make a sweeping statement that this option was not good at all. That option also brought something to the table, but maybe that is something which is not required in this problem. Okay, cool. So let's look at the solution to this problem that Facebook has adopted. That solution is that it will use a combination of the two approaches. As in most good things in the world, you always have to mix and match every possibility and not take an extreme approach. So what Facebook do here is that they actually shard all the user DBs, UDBs across. Okay, the screen is struck. Okay. Just hold on for a bit. Let me actually connect it once again. Can you guys see the screen now? Yeah. So the first thing that they do is they would shard all the user DBs across all multiple DCs. So what does that mean? So have we used the term UDB before? Have we used the term UDB before? Okay, no. So UDB in Facebook's terminology is nothing but user DB. So user database. So what kind of tables? So let's say all the tables that we discussed, that user to friend mapping, user to post mapping, user details. So all these things come in the part of UDB. Does that make sense? So everything which is specific to the user, which was being persisted in the DBs, which was being saved, stored in the DBs, are now sharded across multiple DCs. So what does that mean? That means that, let's say, in US East Coast, in US West Coast, let's say there is a box here, there is a box, multiple boxes, right? Multiple storage boxes. So before this problem of multiple DC, we discussed that users are sharded amongst these boxes, amongst these relational databases boxes. But now the users are not only sharded amongst these boxes, but also sharded amongst data centers. So what does that mean? So maybe user one ka data sits in the US East Coast in this box. Maybe user 2 ka data sits in US West Coast in this box. Maybe user 3 ka data sits only in US West Coast in this box. Maybe user 4 ka data sits in this box. Does that make sense? So we have now not only sharded amongst the boxes in a DC, but we have also sharded these persistent storages across DCs. Does that make sense? Does that make sense to you guys? Cool. So this is the first thing that they do. Right, exactly, you say. This is the first thing that they do. The second thing that they do is that all the caches that they had are replicated across DCs. So what does that mean? That means that all the serving that you are doing, all the read serving that you are doing, most of it, because not everybody in the world is going to do infinite scrolling, and not everybody in this world is going to be very, very free, which is going to actually hit the US DBs in the Facebook DBs. Instead, most of the requests are actually handled by the cache itself. That is why you would want to actually replicate all the cache across all the DCs. Does that make sense to you guys? So we use a collection of approaches. We actually replicate all the caches and we actually shard the user DBs. Does that make sense? Does that make sense, guys? Right. So Moez says, are we only talking about the global cache for replication? Makes sense. So we are only, so every global cache that we had was replicated now. So every app server level cache that you had would still be located at the specific box that it was at. Okay. But just because that happens, maybe you would want to bring a few more things to the global cache and move them out from the app server cache. Does that make sense, Moez? Okay. So I will definitely take an example and discuss every single use case that you guys can think of and tell you how the data will be moved across DCs and how things will be done. Okay. Okay. So Abhishek says, what about non-user DBs? Are they not sharded? So I did not make any claim about the non-user DBs. So let's say, so that you can decide on a case-to-case basis. I would suggest that you can for now assume that for our purpose, for Facebook news feeds purpose, whatever DBs was there, whatever storage layer was there, let's assume all of them were sharded across DCs. Does that make sense, Abhishek? Only a very few corner cases would be there that in our approach that you can say would not be sharded. So for now, assume that everything in the storage layer would be sharded across DCs. Does that make sense? Okay, Nikhil, we will discuss that. We will discuss that. Okay. So let's actually take an example. Let's actually draw this diagram out and let's take read, write, update, whatever example we want to take and see how things are going to be handled. Something that can definitely happen. Exact. Okay. So Lokesh says user data means user ID, password, etc., or user made posts as well. So user data location UDB actually means that the database which has a mapping with users. So let's say a database which has users as a field, all that you can call as a user DB. So you can include user ID, user password, user name, profile details, and so on and so forth. You can include, let's say, the post that the user has made. You can include the friends that a user has, and all these things can actually come inside the user DB. Does that make sense to you, Lokesh? Okay, good. Let's now actually draw it and see how things are actually going to take place in the entire thing. Okay, cool. So you have one client here. Let me draw smaller in a smaller manner this time around because I'm going to have multiple load balancers. Now you have multiple load balancers here. So let me say LB1, LB2, and maybe let's say LB3. Now, every load balancer would have some boxes, app server boxes. Let's say this is DC1, DC2, DC3, this is DC1, this is DC2, this is DC3. You are going to have a global cache. Oh, sorry. So, you are going to have a global cache for DC1. A global cache for DC2 and a global cache for DC3. Does it make sense? Ashwini, that's great to know. I also find it very interesting. If you're finding it interesting, that's very, very heartening to know, Ashwini. Okay. So we have these app server boxes, and then we are going to see these storage boxes. And then there will be cold storage. Let's not discuss about that at this point in time. Cool. This is what we have. Now let's see how things are going to happen. So first kind of a request is a write request. Does that make sense? So let's say you want to make a post. Let's say you want to make a post. Now the client will actually go to the DNS, will actually fetch a list of IPs, let's assume the IPs that it got was something like that. So it got IP2 first, then IP1, and then IP3. So the client will follow the waterfall model and will go to IP2. So it takes it to the load balancer 2. Does it make sense, everybody? Does it make sense to everybody? Cool. Now I am making a write request. Okay, so what will happen? The load balancer will say that, okay, man, you want to write something. And we discussed that writing actually happens. Writing actually happens. You actually go to your box, make a write, and actually store persist that in your specific DB where you actually have that thing, and then also update the cache, the global cache, with a new post ID, with a new user ID, comma post ID, comma timestamp thing. Does that make sense? Now, let's say, just because you are wanting to make that post, let's say the user DB, user one's DB was actually here. So his data, let's say, was stored in this particular box. So what will happen? The load balancer will actually, there are two ways of going about it, which is essentially the same. One thing that you can tell the client that, hey man, can you please hit this IP to make the request? Or you can actually just forward that request somehow to the correct load balancer and get that post executed. We are not going to go into that detail in this curriculum, but appreciate that you are actually going to tell the user somehow make that post persist in the specific user IP, user box. Does that make sense, people? So now what will happen? Now what will happen? This request will actually make sure that this user ID, user box is updated. Okay, this will be updated. And here you will have, with that user ID, have that new post ID and timestamp mapping added. Does that make sense, everybody? Okay, cool. Once that is done, we discussed that every post gets added in the global cache as well. So here you will see user one, post ID something, and timestamp, this post being added. That's it. So you will tell back to the client that, hey man, I have written your request. Does that make sense? Now, these global caches are going to keep on talk to each other and are going to replicate themselves at a fixed interval of time. Okay, so let's say every minute, every few seconds, or let's say they will keep on syncing amongst themselves. Or let's say the moment a post is written here, they would just add it to a queue, and based on how free your network is, you're going to understand that how quickly that syncing can take place. Right? There are two ways again here. One is a pull-based mechanism. The other is a push-based mechanism. A pull-based mechanism would be that you simply say that every frequent interval, every cache is going to talk to every other cache and say, yaar, give me the data that you have now, which is a pull-based mechanism, that you going to the other cache and saying that, hey man, do you have anything new? Let me know. The other is a push-based mechanism, which simply says that you are the one, the moment you record an entry, you somehow push that to the queue of this cache and maybe to a queue of this cache. And based on how free the network is or how free the resources are, it would depend that how quickly that syncing can take place. Does that make sense to everybody? Right. So amongst these caches, these global caches, you are going to have replications. In Facebook's case, they are going to most likely have a push-based mechanism. Why that? Because in a frequency-bound pull-based mechanism, the problem is that you have already set a very strict lower bound on yourself. Even if the network is free, even if something, even if let's say there was a very, very bad day for Facebook and nobody was using Facebook and Sankalp was still using it, but still if it's a pull-based mechanism, you would have to wait before that post can be persisted, right? Right. And also in case of these frequency-based pulls, another problem is that you may actually end up consuming a lot of network bandwidth for that particular point when of syncing up is happening. Does that make sense? Just because you have aggregated a lot of things to be moved at a particular frequency, then you are actually going to clog your network at that frequency. Does that make sense to everybody? But that does not mean that does not mean that pulling is never an option. That would be an option if you are fine with, let's say, having a larger frequency. Let's say you are fine with making sure that you are synced up every 6 hours. That's fine. And you would not want to, let's say, keep on pestering the other one with the new request that you are sending. You would want to, let's say, have a time at which every one of you syncs up, and then a pull-based mechanism would be very nice to implement. Does it make sense to everybody? Okay. Do you guys appreciate how a write will happen here? Now let's actually look at some effects of which we actually see at Facebook, just because this is the way when writes are happening. So let me tell you one example. One example that I have seen many times, and I am assuming that some of you would have also seen. Let's say you log into Facebook using your mobile app. Okay, let's say you log into Facebook using your mobile app. You are browsing through your timeline and you see a post. You liked that post and you liked it. Does it make sense? You are very happy seeing that post and you press the like button. Now let's say you actually go again, log in from your web browser. You log in through your PC and log into Facebook again. Have you seen instances that at that point in time you are again seeing that post and that post is still not liked? Have you guys seen that? So you have made a right call a minute ago from your application, mobile application, where you liked a particular post, but on your web browser you cannot see that post. You are the same person. You liked it just a few minutes ago and you are not seeing that on a different device. Why is that happening? Because maybe your app was connected to this load balancer. Maybe your app was connected to this load balancer. It did something and it got persist and it made an entry in this cache. And maybe your web browser gets connected to this load balancer, and when it's seeing that post, it is not seeing a like there. Does that make sense? Because the replication is going to take some time. Okay, and when this replication takes place, then your browser will also start showing that this is a post that you have liked. Does that make sense? Now Nikhil is saying, is it because it's not a pull-based mechanism? Guys, you tell me. Is it because, does it tell us that Facebook is using pull-based or push-based? Or can we not comment on it still? Can we comment on it? Whether it's pull-based or push-based? We cannot comment on it, right? We cannot comment on it because the problem here is not push-based or pull-based. The problem here is consistency versus availability. Do you guys understand that? Are things starting to make sense now? The problem here is not about pull or push. It's about consistency versus availability. Facebook here had made a conscious decision of preferring availability over consistency. What does it mean? It means that Facebook is fine with having eventual consistency just so that it can have availability. What does that mean? It means that maybe there is a lag between syncing up between this cache and this cache. Do you guys appreciate that? Maybe the connectivity between these two caches is broken, or maybe there is a lag, or maybe something bad is happening. We don't know what is happening. There is some kind of a partition here. Facebook had two options, either to say that I am not going to accept a like from you. Tell the man that, hey man, you want to like it, but I'm sorry, I am not able to connect with every single global cache on this planet that I have. And just because I'm not able to do that, I'm not going to accept your like because I am stupid and I want it to be consistent. Right? Facebook has said that no, that is something which we can avoid. Instead, saying that I would want to be available. Somebody wants to have a like, give them the feeling that yes, they have liked the post. But maybe some of the data centers, some of the global caches are yet to update it, but I'm fine with that. So I am preferring availability here over consistency. Does that make sense? And the consistency that you see is nothing but eventual consistency. Within some time, you will definitely see that like, right? Cool. Now there is, okay. Am I going a bit too fast today? That's primarily because I want to get done with Facebook newsfeed for once and all for good, so that we all know how to design Facebook newsfeed, right? Cool, cool, cool. So, okay, cool. Okay, cool. Now there is one thing more. Just because this is the kind of a behavior, you would want to realize that there are some kinds of sanity checks that you will have to make. What does that mean? That means something like this. So let's say you liked a post here at your app. And now let's say you are seeing on the web browser and you are seeing that, yeah, वो like तो हुआ नहीं हुआ है. You liked it again, feeling that something, maybe I missed it. Facebook would not have missed it. I liked it, but maybe I am not very sure whether I liked it or not. Let me like it again. And if you like it again, you would want to ensure that once these eventual consistency happens, once you are making this data flow, what will happen? Cache 1 will tell cache 3 that, hey man, there was a like that I saw on this post from this guy. Cache 3 will also tell cache 1 that there was a like that I saw from this guy. You need to be intelligent enough to assume that this like is the same like. Does that make sense? So if you are counting the number of likes, you cannot simply aggregate what cache 1 is saying and what cache 2 is saying. You will also have to take into account the duplicate user IDs that there may be. Does it make sense? So just because you are preferring eventual consistency, you can force your user to make the same action multiple times, which otherwise he or she would not have done. But just because you want to prefer eventual consistency and you want to prefer availability, you need to take into account that this becomes a possibility now. Does that make sense to everybody in the class? That this becomes a possibility. You may have to have several sanity checks just because you don't have immediate consistency. Cool. We discussed that completely. And how did we come here? We come here while discussing how to make a post right. Okay, Nikhil has a doubt. Nikhil, do you want me to unmute you? Nikhil, do you want me to unmute you? Sure. Hey, Nikhil.
Yeah. Hi, Tarun. So yeah, I was one small doubt only. So let's say our mobile and web both are connected to different DCs, right?
Uh-huh.
And I liked it from my mobile, and then as you said, I observed it over my laptop. It's not there, so I clicked the like, right?
Makes sense.
So let's say my laptop was connected to DC2, right?
Mm-hmm.
And then that request, shouldn't it be redirected to DC1 kind of thing where my user data will be there?
Okay, makes sense. So let me just, before answering that, let me just tell you how read requests will happen. And once I am done with that, then maybe we can have a discussion if you still have that up. Okay, Nikhil?
Yeah, cool.
Okay, cool. So let's now discuss, we have discussed how writes will happen. Let's now discuss how reads will happen. Okay. So now let's say there is a new user who wants to read his news feed. Let's say he got some list of IPs. So let's maybe use a different color pen and say this client got this list of IPs. He got IP3 first, IP2 first, IP1 last from the DNS. Now this client is going to make a call to load balancer 3, a read call. Do you guys remember that reads, most of the reads will happen from the cache? Does it make sense? And we are fine with having eventual consistency. We don't want to have immediate consistency. So what will happen? I will look at, first of all, I will look at the global cache and see if I have a newsfeed for that user in that cache. Do you guys remember I also had a cache for newsfeed to user ID to newsfeed ID? Do you guys remember that? So I will see if I have a newsfeed there. If I have a newsfeed, I will send that newsfeed to the user. In the meanwhile, I will, from this global cache where the posts are stored, will check how many new posts are there, and I will update the user ID newsfeed here by looking at the new post and will reply back to the client. The point is that this particular user may be situated at this particular box at a different DC altogether, but I am not worried from that. I am fine with whatever DC this user gets connected to. I am fine with giving back a response with his newsfeed from that DC only. So there may be, okay, okay. So there may be some of the posts that are missing in this cache, but I am totally fine with replying from here only because I am fine with eventual consistency. Within the next couple of refreshes, I am actually going to see new posts being added here, and then I will reply back with that. Okay. Okay. Now there is a genuine question, but for friend list, it will go to DC1, right? So that is why at the beginning of this class, I told you that there may be a few caches that we would want to move from the app server to the global level. So friend list cache is going to be one which now makes total sense to have at the global level rather than having at the app server level. Does it make sense? App server level. Does it make sense to people? Okay. Any other question that you want me to answer? If there are some people who want me to repeat it, please write repeat it. Okay. So Lokesh says, how will the user log in? Makes sense, Lokesh. So Lokesh, authentication is one single request. Does that make sense? So let's say you want to log in. That's a one-time job for that session. So maybe for the authentication request, you will be redirected to the load balancer where you actually are. Or maybe internally the load balancer will check with that particular DC and see if you actually can be authenticated or not. But the moment you are authenticated, now your connection can be maintained at any different DC, irrespective wherever your authenticated data was. Does that make sense, Lokesh? So maybe for one request, you will have to go to your exact load balancer where you actually have that data. But for every subsequent request where you just want to check if whatever is the latest news feed, you can actually go to a different box. Lokesh, does that make sense? The point here is that we would not, Facebook in reality does not force you to go to the data center where your data is located. Does that make sense, Lokesh? And why do we do that? We do that because we want to ensure that the data is as equally spread across data centers as possible. Does that make sense, Archit? Lokesh, does, oh, sure, Lokesh, I can unmute you. Hey, Lokesh.
Yeah, hi. Can you hear me?
Yeah, we can hear you.
Yeah, actually, suppose we have done login something like this, means what I understood, but how we will maintain the session? For example, like every time when I will open my browser, it will ask me again login because it can go to any load balancer.
Makes sense. So the point is that you will not be going to a different load balancer all the time. So you will be going to only, so let's say in a session, it's very unlikely that you actually cross load balancers, that you stop communicating from this and start communicating with somebody else. Point one, because, so let's say you are, so do you think you make a DNS call all the time before every request? No, you do not ask for an IP from the DNS after every request. You have got one IP, which you are going to utilize for this session. It's not as if you are going to change it. There may be some very, very extreme circumstances in which you actually change your load balancer IP in a single session. Extreme circumstances that like maybe that load balancer being down, or extreme circumstances like you actually accessing a particular website while you are commuting. So let's say you are sitting inside a train, you are actually moving from a city to city, and now let's say you change networks, and then maybe a new DNS call is made, you actually go to a new load balancer. In those extreme cases, you would be asked to sign in again. Does it make sense?
Got it.
Because your session would be lost. But in other normal circumstances, myself sitting inside my house, my Wi-Fi working totally fine, I will not be making multiple DNS calls. I'll be making one DNS call, getting a particular IP, going to that IP, saying that, hey man, I want to have a connection. And maybe for that connection, internally, they are going to reroute that request to a different load balancer and check from that DC whether this guy can be authenticated or not. If I can be authenticated, I will be establishing a connection with this DC only, where I made the first call, getting all the data from there and doing everything perfectly fine from that DC. Does that make sense?
Got it. Got it.
Every write request that you are going to do will get redirected to the particular data center that you actually are stored at, your UDB is stored at, but that is something which is relatively less frequent, and that is something which we are fine with having delayed, having some extra latency, and we are totally fine with. So let's say there are two kinds of writes that you're going to make. One is that you are actually going to, write a post. We are totally fine with my browser taking some time to write a post. Does that make sense, Lokesh?
Yeah, yeah.
The other kind of a right that you have is that you want to like a post. The browser will let you know that, okay, man, you have liked it, irrespective whether he just cached it at a local DC's cache only. But within some time, it will be cached in all the DCs and will be persisted in your particular user DB, and we are fine with that kind of a latency as well, right? Does it make sense?
Yeah.
Okay, thanks a lot, Lokesh, for asking it.
Thank you.
Okay, so up now, Sankal, do you want me to unmute you? Ashwini, do you want me to unmute you? Okay, so let me unmute Sankalp, and then I will unmute Ashwini as well. Hey, Sankalp.
Hi, Tarun.
Yeah.
Yeah, so my question is basically, does the user data will always remain in the same data center?
Yes, in normal circumstances, yes. But so actually, you would realize that it's basically a consistent hashing at two levels now. Good that you brought up that point. Let me just actually write it, and I would want everybody in the class to appreciate that they get it. You now have consistent hashing at multiple levels, right? There would be a consistent hashing first of all at the DC level. That which particular DC does this user sit at? Then there would be a consistent hashing for amongst the boxes level, that okay, you are inside this DC, but which particular box does this user sit on? So there will be two levels of consistent hashing. You remember that we discussed that consistent hashing allows you to reallocate data from one DB to another, one box to another. Do you guys remember that? Sankal, do you remember that? So let's say a box goes down, you can actually use consistent hashing, will automatically transfer that data from one box to another. Sankal, do you remember that?
Yes, yes.
Okay, so similarly, but at a very, very less likely probability, you can have a user moving from one DC to another DC, but that is a very, very low probable issue. Maybe if something, let's say some part of a DC is down for a longer amount of time, maybe then you would want to do it, but that's theoretically possible. Practically would not be happening at a frequency. Does that make sense, Sankal?
Yeah, and you also told us that we are somehow utilizing the time zone difference in the countries. So how are we using that? How is Facebook utilizing that to?
Right. So just because I am not forcing a user to go to his or her own DC only, just because I am catering to every request with every DC as nicely as possible, that is why I am utilizing the seasonalities of actual usage. Why? Let me tell you. So let's say it's daytime in India and it's night. So this was consistent hashing. So let's say it's daytime in India and it's nighttime in the US. Let's, without loss of generality, assume that in daytime in India, the number of requests are going to be very, very high. And the number of requests in the US is going to be very, very low. Does that make sense? Now, just because Sankalp, my Indian user is equally likely to go to the US East Coast, US West Coast, India, I am equally likely to go to any of these places. Do you understand that when very high number of requests are coming off India and very low coming out of US, even then all of these DCs will be equally loaded?
Yeah.
Sankalp, does it make sense?
Yes, yes.
And similarly, when it's daytime in the US, all of them are equally likely to land at any of these DCs, and still the DCs would be equally loaded. So, why they are equally likely to land? Because the DNS is going to shuffle them. Point one. Point two. What was the point that I wanted to make? Yeah. If this was not the case and Facebook was actually routing you to the present to your own DC, then the problem would be that in the daytime in India, this DC would be very much loaded. In the night time in India, this DC will be very much low. Does it make sense?
Yeah, got it.
Sankalp, does it make sense?
Yes, yes, got it.
Okay, thanks a lot, Sankalp.
Yeah, thank you.
Okay, Ashwani, let me unmute you now. Hey, Ashwani,
Hi, my question is that how to maintain the session the Facebook
how to maintain the?
session in the Facebook.
Right.
Let's suppose I log into my user in the India DC.
Okay.
After that, I move to the US
Nani, how do you move to the US?
by plane.
By okay, so okay, so so you actually take a flight and you go to the US. Okay, then
Okay. That time my Facebook account not asked to login again.
yeah, it will ask you to log in again. Most
But
likely.
in that scenario, some in the media.net, he
Uh-huh.
asked me it's not good if login again. How to maintain?
Okay. So how to maintain the session if you actually fly to the US and the session will be maintained? This is what you were asked.
Yeah.
Okay, I'm not sure if the question would have been exactly the same. So I actually worked at Me.net for quite a while, but I do not see the exact same question being asked. But how to answer that most likely is that you would want to actually have some things cached at your client side as well. So let's say, so first of all, did they actually ask you not to be asked to re-log in, or did they actually ask you to maintain some kind of a cookies or some kind of a session after you log back in?
Relogin.
Okay. So Ashwini, the point here is that first of all, why would they want you to relog in? Even if they could have avoided you, that's primarily because of the security issues. So let's say I am somebody who always accessed my Facebook from India. I never venture out of India. I do not. Facebook knows that this guy is very, very boring. He always accesses his Facebook from India only. Never ventured out. And now if I actually in the US and I'm trying to access Facebook, for sure irrespective whether it's Facebook or Gmail or any other service, they would ask you to relog in. You would have noticed that if you access VPNs, they would say, Google would say that, hey man, your account is being accessed through US IP. Is that, are you sure this is you? So for security reasons, they would want to make sure that you actually relog in. Now, let's assume we throw out security reasons of the window and we still want to say, no, I know that this is the guy who was already authenticated. In that case, the only leverage that you have in your hand is your client side caches. You can maintain cookies at your client side. You can maintain a cache at your client side, knowing that yes, this was authenticated at this time, and this is the time to live for this authentication. The next time I am going to make a request, the session would be dropped from the server side for sure. The server is not going to wait for you and to maintain the session wherever you are going in the world. You are now going to send that key that you received before from your client, and the server can say, okay, this guy was authenticated and this authentication is still within its time to live limit, and I would be fine with interacting with it at this point in time. But this is something which I do not see any big organization doing at a realistic level. Does that make sense to you, Ashwini?
Okay.
Does that make sense completely, or do you still have some doubts?
No, makes sense.
Okay, that's great. Okay, so did you manage to actually clear the Media.net interview?
In the second night, no.
Okay, so was that for SD2 roles?
SD1.
Okay. In SD1, they actually asked you a high-level design question.
Yeah.
Okay, who was the interviewer?
I think
Sorry?
Prabhat.
Bharat.
Prabhat.
Okay. Cool. Okay. Okay, Shani, thank you. Do I need to unmute anybody else now? Okay, Vijay, I can do that. I was also asked the design of tiny URL. Okay, yes, that's again a good question. We would be discussing tiny URL design. Did we discuss that already in this class? We did not, right? Did we? Oh, we did not. Okay, so I will be discussing that. Any other questions? Sukanya has a question. Sukanya says, actually the power went off and it came now. I will need to go through the class. Can I ask? Yeah, you can do that, Sukanya. You can do that. Cool. No doubt. I see now. One question: what if the DC goes down? We'll have a backup of the entire DC. Right? Makes sense. Makes sense. So Neeraj's question is that what happens if the entire DC goes down, right? So first of all, that's a very, very unlikely scenario. That will only happen, let's say, if a natural calamity hits that place. So let's say a natural calamity hits China tomorrow, then Chinese DCs are down. Let's say a natural calamity did not hit China, but let's say Donald Trump's wrath hit China, and he said that every company in the US who is in the US is not allowed to store any data in the US outside of US, or let's say not allowed to store any data in China. Then that's also a kind of a calamity for China. And if that happens, then also the DCs will have to shut down. So yes, if the entire DC, and he should actually do that, right, Lokesh? So what China is doing at this point in time for the entire world, maybe it's right time for the world to gang up against them. And okay, so we can actually, let's assume I did not say that, because that would not be safe for work. Any Chinese in our class? Okay, so let's actually try to assume that we did not say that. Cool. Let's come back to what we were discussing. So yes, okay. So we were discussing that yes, what if the entire DC goes down? What if the entire DC goes down? What happens then? So we said that having multiple DCs all across the world will indemnify you against the losses. What happens if a particular geographical location is hit with something bad? Okay. So now how do you indemnify? First of all, your live requests that were coming to that particular DC would now be settled by some other DC. Does that make sense? This is point one. The point two would be that you already have data backed up across multiple DCs. So we discussed that we have replicated servers, we have cold storage servers, we have archival servers. So you can very well assume that all the data that is in India would be backed up in, let's say, US as well, would be backed up in Europe as well. Does that make sense? Unless and until, so yeah, let's not go into that. So that will be backed up in those places as well. So if a DC goes bad, you can actually create a new DC or actually have the other DCs work for you. Okay. So Uzair, I did not get that question. Uzair, do you want me to unmute you? When do you think that will ever happen? That will not happen. Uzair, do you want me to unmute you? Yeah, cool. Hey Uzair.
Hi sir, am I audible?
Yeah, you're audible.
So like as you said that if a user logs in from application, he likes some post. So it will be short. Then again, if he logs in from his from a browser, so he might not seen the like on that particular post.
Right.
So like
right.
Yeah.
So, so your claim is that will that be written in the user DB twice? That's not the case for sure. That's not the case. Let me now tell you. First of all, when the user is logging in again from a web browser and is seeing a post, and he or she sees that the post is not liked. So first of all, that operation is a read operation. Do you understand?
Yes.
That operation is read operation, and we are totally fine with having eventual consistency in reads, and we are totally fine. Cool. Now when he clicks like, the app will automatically, the browser will automatically show, the client will automatically show to him that your post has been liked. Now what will happen? You will maintain a copy of that like in that particular cache in that DC. And now you will tell the other DCs to also record your like. And you will also tell the specific user DB that there is a like at this timestamp from this user. Now, as I told you, the moment you allow for eventual consistency and still allow people to keep on writing things to you, you need to maintain sanity. So before you actually insert to the user DB, you will have to do that sanity check, that was this post already liked by this user. If you see that yes, this was already liked by this user, you would not want to like it again. Else you will want to persist it again. Does it make sense, Uzair?
Yes.
You will have to have sanity checks there as well, so that it only gets persisted only once.
Yeah, got it, sir.
Okay, thank you. Okay. Any other question, anybody? So this was doable. This sanity check was doable because a user can only like a post once. But let's assume a random application where the likes are not linked with users. Let's assume you are building a social networking website where the likes are not mapped to a user. Okay, where a user can actually like a post multiple times. Let's assume some random application. There you would actually have some bad data also. So let's say you actually showed a user at an app and he liked it. He only wanted to like it once, but just because he went to the browser and saw that his post was not liked, he liked it again only when he only wanted to like it once, but still your DB may end up recording it twice. Does it make sense to you guys? Cool. Yes, Nitesh, you are absolutely right. Cool. Should we move ahead now? Should we move ahead? Any question till this point in time? I hope not. If there is any, I'm still figuring out what should I discuss next. So did we discuss everything? If you have any question, feel free to write. I will be more than happy to pick it up. Let me just check if we discussed everything. So we have multiple data centers. We now discussed how reads are going to happen. We now discussed how writes are going to happen. We discussed that some of the things are going to be some of the things are going to be replicated, that user DBs are going to be replicated. We discussed that the caches are going to be, the caches are going to be replicated, the user DBs are going to be sharded. We discussed that. Let me now, let me now actually write it once so that I can sleep peacefully that yes, everything was covered and nothing was left out. So in case of read requests for Facebook, you would first of all know that read requests are more frequent than write requests. I hope there is no doubt in this. Point one. Point two, read request in the present design can happen from any DC. Is that also right, guys? Okay. Third point, we are fine with eventual consistency. Okay. Fourth point, which is just a culmination of the third point, that we are preferring availability. We are preferring availability over consistency. Does that make sense, everybody? For the read request, this entire thing we have written. Let's now come for the write request. Okay. First of all, you will say that every write requires update in cache plus DB. It requires an update in both of them, a cache in a DB. And just because it requires update in DB, and we know that user DBs are sharded, so it means for write, you will have to go to your specific DC. Does that make sense to everybody? Does that make sense to everybody? So for writes, you actually go to your specific DBs also, specific DCs also. Okay, cool. And it will take some time for the caches to be replicated across all DCs. So your write will also take some time before it is reflected to the entire world. So will take some time before it is shown to the entire world, as caches will take time to replicate. And why is that? Again, the same point. Again, the crux of the matter is that you are preferring availability over consistency. Does that make sense to everybody? And maybe you can add another point that you will have to do sanity checks, because just because you have allowed that, you will have to do sanity checks. Cool. Now let me see if I missed some questions in between. There's a question from Archit. Can ask some questions to verify. Did not get it, Archit. If you want me to unmute you, I can unmute you. Bodhitwa says every DC has a backup somewhere of data in it. Yes, Bodhitwa. Every box will have a backup, and those backups will be spread across DCs. So you should not worry if a particular DC is on fire. You will have the data persisted somewhere else as well. Now, Nikhil says, can we say anything for alone working replicate approach? Why? Nikhil, I did not get it. Do you want me to unmute you? I can unmute you. Bodhitwa says, write request. Second point, can you please repeat how the user is sent to its DC? Can't recall. Okay, Bodhitwa. So Bodhitwa says UDBs. Okay. So for write, you will actually have to make a request to your specific DC as well. That is because Bodhitwa, for a write, you want to write to your specific user DB as well. Does that make sense, Bodhitwa? And your user DB is only at one particular DC, and that is why you will actually have to make a call there. Does it make sense, Bodhitwa? But how am I sent there? Okay, that we did not discuss very detailed fashion in this class, and that is on purpose. But you can actually assume that there are two ways of doing it. You can actually tell the client that you make a request to this particular load balancer, which is a bad way. The better way would be that the load balancer the systems would in themselves have a mechanism of syncing, have a mechanism of forwarding requests, getting requests, maybe using some queues, and telling a particular DC, telling another DC that, hey man, this is a request that I have for you. Let me know once you do it. Okay, Bodhitwa? Sukanya says sanity check here. What does sanity check means? Sanity checks. So Sukanya, we discussed that just because you are allowing different, for the users to interact in case of eventual consistency. So a particular user liked a particular post, but when he accesses the same post from some different browser, he sees that he has not liked it. He can still like it again, but you now need to maintain sanity that this user can only like this post once. So you will not count the number of likes as 2 incremented by 2, but will only count the increment as 1. Does that make sense, Sukanya? So you will want to have some sanity checks. This is what I meant by having sanity checks. Yes, Moise, same goes for views as well. Nikhil says, can we say anything alone? Okay. Alone working replicate approach on consistency availability. Nikhil, I will unmute you. That is not very clear what you want to ask. Uzair, yes, Facebook have them. Okay. So let me now unmute Nikhil. Nikhil, can I unmute you? Okay, sure. Okay, Nikhil.
Yeah, hi. So it was a small question only. So basically, initially we discussed for the working replica copy within the DCs, right? Entire replica copy of complete within
okay,
each
so you are saying if we chose that solution, that we are going to have the entire replica. We are going to have all the boxes, all the DBs, all the caches being replicated across all DBs. This is what you want to say?
Yes. Oversell we can
was
say
the solution that we chose, Nikhil. Even then, you will still have to make a call. So let me tell you how things will happen then. If you have actually replicated everything all across, now you would realize that even if you are at a different DC and you have and you want to write something, you can still write there as well, because you have a user DB for that particular user in that DC as well. But the point here is, still you need to take a call. Would you actually tell the user that your write has been recorded only after writing at your particular DB? Or will you tell the user that your write has been recorded after you make a write to every other DB, every other DC's DB? Okay. If you do the second approach, that you actually ask the user to wait, tell him only when you have persisted that thing all across the DBs, then you will be saying that you are preferring consistency. But that will mean that you are actually compromising on availability, because if any one of them is down, you will not be available, and so on and so forth, right?
Yeah, makes sense. So here also some cases will come. Cool.
Yeah. Here also the same kind of a decision that you have to take.
Cool. Thank you.
Cool. Thank you. How send request on app server box? Arjit, let's not go into that. What if we click on like and then again click it gets unliked, right? Yeah. So when that happens, if you are doing it from one single session, so if you like and then comment, then do another click on it. So it's basically a client side thing that you're talking about. Like and unlike are two different API calls for Facebook. Do you understand that? If I want to like a post, I will not be, if I want to unlike the post, Facebook at the backend will not be calling the same like API again. It's only the client side thing that you see, that when the client sees that this button has been clicked and already selected, and if the user clicks it on it again, the client will unlike it for you, but at the back end, it will be calling a unlike API. Does it make sense, Sukanya? And I hope it makes sense to everybody else in the class. That's a good question to ask, but that sort of tells us how the things that are happening at the back end totally decoupled from what you are experiencing as a user. Does that make sense to everybody? What you're experiencing as a user is just how UX designers would want you to see, but how things are happening at the back end may be totally different. Cool. So I think we have discussed this quite in detail. And now I think I can say that we have discussed Facebook newsfeed for good. And we can assume that all of us can build Facebook newsfeeds now. Sukanya says, by the way, how do you get all these data about their system? Have they made it public? No. So they have not made it public, Sukanya. You would not actually see this online at various places what Facebook does. I actually, yes, so I am fortunate enough to actually know how things work at Facebook due to Anshuman. I had multiple conversations with him, and whatever he knew, he told me, and I now know how Facebook works. This is point one. Maybe let's say if we discuss something about Media.net, I was working in Media.net for several years. I know how things work there. So maybe I can tell you systems about Media.net by knowing the things that I knew when I was back there. But are the things that we're discussing about Facebook about today's Facebook? Maybe not. So Anshuman left company Facebook some 5-6 years ago. So maybe things would have changed, but these are the things that would have happened at that time. But irrespective of how things were at that time, the concepts that we are discussing, we are trying to be as up to date as possible. The concepts we are discussing is as state of the art as possible, Moise. Okay, cool. Okay, Ashwini, it's not. Ashwini, it's not. So we are not actually discussing things verbatim, right? So we are not discussing things verbatim. We are discussing things conceptually, right? Even if somebody did not knew how things actually work at Facebook from inside, you can still argue that even then in our classes we would be trying to take you at the similar direction only, right? Do you appreciate it? Do you see that we were able to logically make decisions? It's not as if I am just trying to recreate what Facebook does for us. It's maybe there are several things that Facebook does differently from what we have discussed in class, because we are trying to logically think about it. And then at the same time, whatever information we have about them, I am also trying to tell it to you so that it's not just a logical thing that we are doing, but whatever piece of information we have, you should be able to get it. That's the only idea, right? But we are logically discussing everything. It's not about getting, it's not about copying something here, right? Cool. And we are also able to, so whatever assumptions that we are making, we are also able to map those assumptions to real life things that we see at Facebook. Do you guys appreciate that? So we actually see at Facebook, you make the like, but you are not saying your same like. So this is not something that by design Facebook has told the world that this is what happens, right? But after we tried to come up with a design of Facebook, we can now explain that why that would have been happening, right? Cool. So we have discussed this in quite a great detail. It's 11 already, but now I would want to discuss a bit about are these defined standards for no Moise. So you can never have a system design which works for everything. And if there were defined standards, then companies would not want to hire architects at all, right? Architects would go out of business in that case. The problem is that every new problem has its own specificities, and you can only come up with you will have to know the design properly, and so that you can actually design something which is more suited to that application. There are no one size that fits all. There is no one size that fits all. So yes, that is why system architects are highly paid, and those are highly respected, because you are actually then in charge of designing a system for the company, which can actually make or break the user experience, which can actually make or break your costs that you incur, which can actually change a lot of things completely. So that is why system design is very, very important as you move ahead in your career. This is very, very important. This is actually going to be the differentiator between you and any other engineer. If you know this properly, this is actually going to be the differentiator between you and any other random Joe in the industry. Okay, cool. We discuss this now. Right, Shankar. So now, because I saw yeah Deepika, because I saw that there are people who are actually not very comfortable with CAP, let me actually try to discuss that for the next 20 minutes. Okay. So to discuss that, a good way would be a story that some of you shared with me in the first class, and I knew that story, but that's a very, very interesting story to share. So we will be doing that. But before that, just because we were discussing Facebook, let's actually take Facebook's real life case and see how the problems of CAP arises. Does that make sense? Let's actually take Facebook's real life scenario and see how the problem of consistency or availability will crop up. So let's say a decade ago or more than a decade ago, when Facebook would actually have started, you would know that Facebook started as a service which was open to some some universities. Do you guys know that? So Facebook started from a couple of universities. Okay. Yeah, social network movie everybody has seen. So yes, it started with, is the screen stuck? Is the screen stuck? Okay, let me just reshare it for you guys. Cool. I hope the screen would be visible now. Cool. So Facebook started from few universities. How did they actually, how was the system back then? It was a very, very simple system. You have a client, okay? Let's say you have a load balancer. The load balancer had 2 or 3 app server boxes. Let's say 4 app server boxes, or let's say 3. And then they had a single MySQL DB. This is how Facebook started. They had a single MySQL DB where they were actually storing all their data. Does that make sense, folks? Let's try to enlist a few tables that they would be storing, right? So let's say, yes, Moe, so let's assume they started without any cache. Or let's say they were having some app server caches, which is, let's say, caching the basic information at the app servers, and that's enough. Okay. The kind of tables that they would have had would be, there would be one table for user profile. Is that right? He's storing all the profile information about the user, maybe the link to his image, maybe his name, college, age, gender, and so on and so forth. Then there would be maybe a table for having the friend connections. Does that make sense? Then let's say they would be having a table for all the posts that you're doing. Okay, so these kind of tables they had, and they only had one MySQL box. Okay, but here you would realize that there is a problem of data persistence, right? There is a problem of what happens if this box goes back. Do you guys appreciate that? What happens if this box goes back? So what did they do? Let's say they had a cron which ran every 6 hours and took a snapshot of the DB. Let's say that snapshot was 100 GB. What is a snapshot? Making a copy of the present state of the DB. Does that make sense? Taking a snapshot, clicking a picture and saving whatever you have at this point in time. They take a snapshot every 6 hours and then persist that snapshot at some other box. Okay, and they delete the last snapshot that they have. So let's say I have a snapshot ID 101. 6 hours passed by. I took another snapshot 102. I will delete it and I will save 102 snapshot here. Does it make sense? This is how Facebook actually worked at the very beginning when it was working for a few universities only. Okay, now, can somebody tell me what are the issues here? Before the issues, so how would all the data will be accumulated? They will be simply doing SQL joins. Does it make sense? So when you have a normalized schema, that is, you have data spread over multiple tables, how do you get the data? How do you make sense out of data? You simply do SQL joins. So they were simply doing SQL joins and things were good. Now, can somebody tell me what are the problems here? What are the problems with this design? Can somebody tell me that? Okay, makes sense. So very first problem would be that with time, as users grow, one box would not be able to fit all the data. Does that make sense? So one box will not be able to fit all the data. This is one problem. The other problem with this present approach would be that just because you are taking a backup every 6 hours, you can potentially lose data for at most 6 hours. Does it make sense? You can potentially lose data for 6 hours. Does that make sense to everybody? So all the posts that somebody made in the last 6 hours can actually be lost if this design was continued to be followed. Does it make sense to everybody? Cool. Now these are the two main problems. Now let's say at that point in time, Facebook hired you as a developer. Let's say Neeraj, Sankalp, Uzair, Nikhil, Abhinav, Parul, you were hired as a developer at Facebook at that point in time. If that would have been the case, you guys would have been very, very rich by this point in time, because you would have accumulated millions of dollars worth of stocks. But yes, okay. So yes, let's say you were hired at that point in time and you were asked to come up with a solution to this. Can you guys think of a solution for this? Can you guys think of a solution for this? Okay. So many of you are giving the right answer, and that's primarily because we discussed that already, right? Right. So anybody who feels that maybe increasing the frequency of backups can be a good solution? Anybody who feels कि यार एक काम करो 6 घंटे की जगह 2 घंटे में बैकअप लेना शुरू करो? Is that a good solution? Right. So if you propose that solution, then maybe Facebook would say, Mark Zuckerberg would say that I did not hire the right person who is coming up with this kind of solution. Why? Let's discuss that. So if you actually reduce your backup time from 6 hours to 2 hours, you are only say reducing the problem of losing data to 2 hours. Okay, you're not doing anything to the first problem. The second problem you are reducing and saying you have 2 hours problem, but still losing data for 2 hours is also a big deal. So that's not acceptable solution. Now, if you are stupid enough to say that I would do backups every 10 minutes, then the problem would be that your network would only be doing backups and nothing else, right? If you do backups every couple of minutes, then your network would only be doing backups and nothing else. Backup is a costly process. You are essentially taking a snapshot and then transferring the entire snapshot over the internet, which is a costly process. Okay, so backup, increasing the frequency of backup is definitely not an answer. So now, as some of you told me, the solution to this that Facebook actually applied was this, that your client remains the same, your load balancer remains the same, your app server boxes remain the same, but your storage layer now becomes something like this. So you have one box, and that box also has another box connected to it. So this you call as a master box. This you call as a slave box. Does that make sense? Does that make sense, people? Okay, screen is not shared. Can you guys see my screen? You can, right? Cool. So there is a master box, there is a slave box. And now, okay, the screen is stuck. Let me actually reshare it. Cool. So I hope you can see the screen now. Cool. Yeah. So now for every layer beyond the network, beyond the storage layer, all of them are still all of them are still interacting with the master only. For them, it's just like they are just interacting with the master. There is no slave. But the master is interacting with the slave and doing a few things. Does that make sense, people? Does that make sense? This is a very, very basic master-slave architecture that they actually came up with. Now, you guys realize that master-slave architecture need not always be like this. Okay, what are the variants possible? You can have multiple slaves, right? You can say that your upper layers are not only talking with the master, but also talking with slaves. How is that possible? So let's say you can say that all the writes are happening in masters, but all the reads are happening from slaves. Does that make sense? But the approach that they came up with was that every layer beyond the storage layer only knows about the master. The master is interacting with the slave and is only doing that to make sure that the data is persisted and the system remains. Mother, you can always switch the master and the slave and do something. Okay, cool. So what do they call the master copy? They call it the active copy, because all the reads are writes and writes are happening on the master only. Does it make sense? They call the slave as a passive copy because it's not in use for any layer beyond the storage layer at this point in time. Does it make sense, folks? They call the master as the active copy and the slave as the passive copy. Now, for reads, the reads are only done from the master, but for every write, they will actually want to persist that write on the slave as well. Does that make sense? Folks, does that make sense? Okay. So they will persist every write on the slave as well. Okay. Now, Facebook actually started with only one slave. Okay. Now, you guys tell me. There are two eventualities possible here. And not only here, two eventualities possible in any system. One eventuality is that a box goes down temporarily. Please appreciate this. There are two eventualities that can happen, and I'm pretty sure that you may not have appreciated that till now. One is that the box becomes unavailable for some time. Okay, and the data is not lost. The other eventuality is that the box goes permanently bad. Does that make sense here, people? Does that make sense? There are two eventualities possible. One, that the box is down for an instant or for some temporary period. The other eventuality is that the box is down forever, right? Here you would realize that irrespective whatever the eventuality is, you always have another box which can actually take up, right? So if this master goes down for some time, this slave can actually become a master, and you can just ensure that you have another slave in place, which can actually just copy data from the slave, and this slave can become the master. Does that make sense? Does that make sense, folks? Okay. The second point is that what happens if the master goes bad forever? Even then, you will have most of your data. Why do I say most of your data? I will just come to that, because there are two ways of handling these writes. Sorry, this was not a read, this was a write. So I mistakenly wrote a R here. This was a write. So we will just be discussing that there are two ways which will eventually lead us to the CAP theorem, and we'll come to that story and end the class there. But you would realize that most of the data would be persisted on the slave. Cool. Now there is one question that some of you may ask, and whatever class that I took before this class, I've always been asked this question, that what happens if both the boxes go down? What happens if the master and the slave both go down? So if that happened, that would have happened if the horoscope of Mark Zuckerberg would have been very, very bad on that particular day, because that is very less plausible. Maybe I discussed this before as well, but I will just point it out once again. The probability of any bad box going down, P, would be between 0 to 1, right? Would be a very small number. So whenever a number is between 0 to 1, then whenever you make a power of it, that number become much, much smaller than the original number P. So that is why the probability of two boxes failing at the same time is very, very low. and you have, so let's take a real example, right? So let's say the probability of going one box going down is 0.1, that's 10%, let's say. Then the probability of both the boxes going down would be, that's 1%, right? And this is a very, very high probability. You are using very cheap boxes if you have 10% probability of a box going down. So let's say this is not the case, but you had, let's say, 0.1% probability of a box failing, then the probability of two boxes failing would be 10 power minus 6. Does it make sense? Which is less than, which is roughly 1 in a million, which is exactly 1 in a million. So now you only have a millionth probability of a box failing. Does it make sense? Cool. So we have discussed this. Now let's actually move directly to the CAP theorem and discuss that for once and for all, so that CAP theorem is there in with you forever. Okay, because that's a very, very important theorem to understand. There are two ways here for the master and the slave to interact. Does it make sense? There are two ways for here the master and slave to interact. One is that you would want to update the slave immediately on every write. Does that make sense? That you would want to update your slave at every single write immediately. What does that mean? That whenever you get a write request, the first step would be that you write here. Second step would be that you write here. Third step would be that you reply back from the slave to the master. And the fourth step would be that you reply back from the master to the slave. Does it make sense? Right. The second option that you have is that you can update the slave periodically, or you can, let's say, lazily you can update the slave. So whenever you have a master, a slave, a write comes, you simply write at the master and reply back to the client that, hey man, I have replied back to you, I have written it, and then lazily somewhere down the line, write it at your slave and then reply back to the master saying that I have written. Does it make sense? There are two possible ways here. Either you can lazily update it or you can update it immediately. Now, let's actually try to look at all the positives, all the pros of the first decision, all the cons of the first decision, and all the pros and cons for the second decision. Who would want to be unmuted and who can list us the pros or cons for the first decision? Whom can I unmute? Okay, Nikhil, for sure. Hey, Nikhil.
Yeah, hi Tarun. So first A approach, what we are doing is we are getting a write and writing in all the replicas and then sending.
There is only one replica for now, but yeah.
One replica
and then replying back. Yeah.
Replying back. So in that case, basically we'll be doing strongly consistent.
Okay. So I would say that you are saying that it's better consistency.
Yeah.
Because you are actually writing things to the slave, only then telling to the user. So even if it goes bad, the master goes bad, you are sure that every single thing that you want to write in the master would be immediately available in the slave. Okay, so it's immediately consistent.
Yes, immediately consistent, strong consistent.
Okay, what next?
And basically,
right?
Yeah, but here availability won't be that much. Reason being,
Why that's
basically we'll be compromising on availability. So let's say basically one of our master like slave was not down for some time.
That's great.
Right?
Okay, so you are saying that, let's say this connection was broken for some time, slave was down, then.
And basically when the write request came and basically let's say it was broken for the some time and by that time timeout came, right?
No. So exactly. So you are saying that you will have to tell back to your user that, hey man, I cannot take your write even though I'm alive because my slave is not alive. Does that make sense?
Right.
Everybody, why we are actually facing lack of availability here? Because even though you are alive, even though the master is alive, you will still have to tell the user that I cannot take this ride because my slave is not alive. Does that make sense to everybody? So the first approach will actually compromise on availability.
Correct.
Can you speak a bit about latency as well?
Yeah, here basically latency will be also more. So basically we'll wait till it's written over to the like both of the slave, master and slave both.
So slightly higher latency as well.
Latency as well. Time will for write it will be little more.
Makes sense. Now let's come to the second approach, B.
Yeah.
B wala approach says कि यार I will directly write to the master and tell back to the client, and then I will at my own lazy pace will reply write to the slave.
Update
Right.
the slave that.
So do you think it's consistent here?
It is consistent, but it's not strongly consistent. Basically,
Right.
as per CAP theorem, C is not there.
Right. And why it's not there, you can actually figure out a reason why. Because let's say कि you wrote something to the master, and the master said that I will lazily update to the slave, and something bad happened, and the master is temporarily down. Okay, the master is not down forever, but the master is temporarily down. Now the slave will become the master. Does that make sense to everybody? When the master is temporarily down, the slave will become the master. And just because the master did not write some updates to the slave, things will not be consistent to the end users. Does that make sense to everybody? So even in case of temporary outages, you will see lack of consistency. So it's less consistent, but is it more available?
Yes.
It's more available. Why? Because even when let's say slave is down, master is up, still master will accept it and say, because I will anyhow have to lazily update to the slave, so I can accept the request at master itself.
Whichever
Okay.
active.
Yeah,
And
will be
basically-
slightly faster as well, so less latency.
Less latency.
So we have discussed this properly now, and we assume try to understand that here the master only went bad for a temporary period of time. If the master went bad forever, then do you see a data persistency issue as well? Folks, do you see a data persistency issue as well? If the master goes bad forever? Yes. If the master permanently goes bad, in the second approach, you will be losing out on data as well. Does that make sense to everybody? Right. Now, there is one thing I would want you guys to appreciate, that why is there a trade-off between consistency and availability? It's only because a partition can happen. Does it make sense? Till the time Facebook was only using one box, till the time Facebook was only using one box, no partition would have happened. Does it make sense? And at the DB layer, Facebook was both consistent and available when it was only using one box. Does that make sense to everybody? So if it was only using one box, no partition could have happened between the DB boxes, and the DB layer would be both consistent and available. What does that mean? The moment somebody writes to the DB, it will always be there for people to see. And till the time that box is up, everybody can access it all the time. So it is both available and both consistent. Does it make sense to everybody? Now, just because I have a network involved in the DB layer, I'm not saying that the Facebook did not have a network in the entire system. I am only speaking about the DB layer. The DB layer of Facebook was both consistent and available when it was using only a single MySQL box. Now, when it started using two MySQL boxes, just because a network was there, and just because a network is there, it can always lead to partitions. The moment your system need to become mature to handle partitions, now you will have to take a call in either preferring consistency or preferring availability. Does that make sense to everybody in the class? Can I skip telling the example that I wanted to tell otherwise? Because I feel now everybody appreciates consistency, availability. Yes, can we skip that? Okay. Yeah, do you want to say something, Nikhil?
Yeah, one just small thing maybe like over MySQL DBs, can we achieve the availability and see basically eventually consistency over there as well.
No, no, so you are saying for multiple boxes or single box?
Multiple boxes.
So in multiple boxes, of course, you can achieve eventual consistency. That is
For
what we are saying.
MySQL.
For my, for yes, you can have any kind of boxes, right? So you can have,
Okay.
the point is it's not about what box you're using. MySQL will only tell you how I'm going to handle in one MySQL box. How do multiple MySQL boxes interact? That's your logic and your design to write. Okay, so you are going to write some kind of a syncing mechanism between the boxes, which is going to enable you to utilize multiple MySQL boxes at a given point in time. MySQL box in itself is a box which talks only about one single box. It's not a distributed database. We do have the latest versions of SQL boxes which can actually work on distributed systems as well. But primarily MySQL boxes, all the advantages of MySQL boxes are there because those are primary single box DBs.
Single box.
Does it make sense, people? So all the kind of extra logic that you will have to write amongst different MySQL boxes is a logic that you are going to write at your end. Okay.
Basically, that we'll have to add it additionally.
Yeah, that you will have to add yourself, right? And then you can take a decision between preferring consistency or availability. Okay.
Thank you.
Okay. Thanks a lot, Nikhil. So I think that we should end the lecture here. I actually want to discuss Facebook Messenger, start discussing Facebook Messenger today, but I see several of you have left the class already. So let's discuss it in the next class. Is that fine? Okay, we will be discussing REST APIs in one of the classes, maybe in this class, maybe in this curriculum, or maybe when we are actually going to do the backend thing, maybe we are going to discuss it then, but in the course, in the entire curriculum, we are going to discuss that for sure. Okay. Okay, Moez, we can discuss Uber as well. We can discuss Uber. Sukanya, that's great. So Sukanya is telling us that due to HLD classes, I was able to solve some design issues in our company and design the design flow the application will develop. That's great to know, Sukanya. That's basically the best outcome that I can imagine. And I have seen that happening multiple times before as well. But I'm really, really happy to hear that you were able to do that. Congratulations on that. And I can assure you that being a developer, you are actually going to grow a lot if you know high-level design properly. It's not only about interviews. It's actually going to help you grow a lot in your career if you know high-level design well. Congratulations on that. We are planning to use a cache too, but not very sure how to implement. Okay, so maybe we can have a discussion. I am very busy this weekend. If you're free, we can have a small discussion the next weekend and discuss the problem that you have at your hand, and we can see if you can how we can go about it. Okay. Thanks a lot, everybody. I hope you guys enjoyed the class, found something new today as well. We discussed things about how to have systems across DCs. That's also a very, very interesting thing to know and a very, very important thing to know. Yes. That's great to know, Nikhil. That's great to know. Okay. So see you again in the next class, folks. Okay, Neeraj. Can you just drop me an email, Neeraj? Then I will be able to do that. Just drop me an email regarding it. I will do that. Thanks a lot, everybody. Okay. So I will look into it and reply to you on floor. Okay. Goodbye. Good night. See you again soon. Bye. Thanks a lot.